Hello and welcome to my YouTube channel. This is Raman Online Mathematics. If you know you have not subscribed, please subscribe and share it for me. Now, we are going to look at a simple thing under the second order PDE, and that is called the canonical form of a second order PDE. Canonical form of second order PDE. This. Let's consider this PDE AUXX plus BUXY plus CUYY plus say DUX plus EUY plus FU equals, let's say, J, okay, of X. Is that okay? Where A, B, C, D, E, F are all function of X, Y, and what? U. Is that okay? Right. So, after getting this, the next thing that we are going to look at is very simple. This A, you know that is a coefficient of the UXX. I already have explained that into you. So, and this B is also coefficient of XY, and the C is coefficient of UYY. The D and the EF, they are not important here. Okay. Now, the idea is that we are going to convert everything from X and Y to xi eta. So, you are going to convert XY to what? Xi eta. Is that okay? So if I'm going to convert everything to this, it means that my U of XY is going to be converted to U of what? Xi eta. So this is what is going to be. So what we do here is that, so let me do this. After you convert it to this, when you get our answer, you come back to this one. Is that okay? Very good. So that's what you are going to do. So now, okay, let's look at how we are going to deal with this. You can see these beautiful tables or trees. I don't know how you call it. And you have seen this thing before. You remember when you were doing the first, and that was a change of variables. Now, I've included this due to the nature of what you're going to do. Remember, we are dealing with second order. Okay, so you're going to learn how to differentiate the U subscript X, that's the first order, and the second order with respect to the xi and the eta. So let's assume that I have UX. You know how to differentiate this already. What you do is that you take U xi, so the U, then you to take the xi as the differential. So it becomes like this, U xi like this. Is that okay? Then this xi become a function itself. Is that okay? And also take this one as a differential plus, for the same thing, I'm here. This side I went to the X because I'm differentiating with respect to X. That's why I'm not going to the Y. So here it will be U eta X. So you see how I go about it. So I'm going to have U eta, then the eta X. Now, if I move on to Y, that one is going to be U xi Y, right? So U xi Y plus U eta Y. Is that okay? So you can memorize it. If you cannot memorize, then use the table, this table. So this is what we have here. What it means is that if I want to get UXX, we are going to differentiate UXX. So look, this is product, okay? So I hold one, I'll differentiate one. So first, let me hold xi x. Then let me differentiate u xi. Now, if you want to differentiate u xi, that's the table for the u xi. So this goes this way: u xi xi. So like this: u xi xi. Then the xi x. Xi x. Is that okay? Then you go again: u xi itai. So u xi itai. Then itai x. Itai x. Is that okay? Then plus. So that one is for the differential of this one alone. Then before I will come and differentiate the xi, because that's what I hold. So now I'm going to hold this one and differentiate this. If I differentiate xi x, that will give me u xi x x. That one, you don't read it from here. So I'm going to have this. I'm holding u xi and differentiate xi x. I'm going to have xi x x. Is that okay? So that one is for only this. Now elevate this side. So now if I want to differentiate this is what I'm going to get. I'm going to have, so now I'm holding eta x constant. Let me bring it down here. If not, I will break your face. So eta x constant. So I'm differentiating u eta. So u eta will be u eta xi, right? U eta xi. Then xi x, because we are dealing with x, plus u eta x. Then here I will hold this constant and I will differentiate. I'll hold this constant and I will differentiate this. So u eta x x. Is that okay? Eta x x. So now that I have this, I'm going to clean this, okay? Next time when I'm doing the second one, which is the u y, the diagram will not be there, so you can screenshot it and try to understand the diagram. So in this case, what I'm going to do here is that I'm going to multiply this one through, okay? So if I multiply this by this, u x times u x, that will be u x squared. So my final answer of this becomes u xi x squared plus this multiplying by this. You have u xi eta x eta x, okay? So I'm done with this one, plus u xi x. Before I will come here, this multiplying by this, I'm going to get eta x times this. You see, it will be u eta xi x eta x. But this one I can interchange the position and write it xi eta. It doesn't matter. The position, the arrangement does not matter if you remember the beginning of the video. The first order, I explained that thing to you. So I'm going to have u xi eta xi x eta x. So if you multiply this by this, that's what we're going to get. Eta x times eta x will be eta x squared. So that will be u eta x squared plus this, which is u eta x x. So now we have u x x equals, you see, this one and that are the same. So we can have u xi squared x plus 2 u xi x eta x plus u x x. Then you move to u eta x squared. U eta x squared. Lastly, u eta x. Very good. So if you want to differentiate it two times, that ux, that the second order, this is the formula you are going to get. But for one time, it will be u xi x, u eta x. That's all. Okay, now if I'm moving to the next one, we already know ux to be u xi x plus u eta x, right? So if I want to find u xy like this, means that what I'm going to do here is that already this the ux is this one, okay? So I'm now going to differentiate it with respect to y. So what I'm going to do is that here is going to be u. So I'm going to hold xi x, okay? Then I will differentiate u xi. Remember the table. So the table is saying that you should go u xi 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 y. Now here I will move to the y. The reason is that I'm differentiating with respect to y. You see the x come for ux, that one is here. So with respect to y, then I'll hold my this. That's a product. Plus, now I'm going to go to the eta side. So I'm going to have u xi eta y. Is that okay? Then plus, I'm done with this one. I'm now going to differentiate this. So I'll hold this and I'll differentiate this. So this will be u xi. Now remember this one, differentiating with respect to x, so it will be xi x y. The x is already there, but with respect to y, so the y counts. Is that okay? Now we move to the second one, which is u. So here I'm going to hold first. Let me hold the eta x. Then I'll differentiate this one. Oh, always. Let me bring it here. So I'm holding eta x. I'm differentiating u eta xi y plus u eta what y. So that then I'll hold this differentiated. This will give me u eta x y. This one you are going to do. So if I simplify this, now this is going to be u xi x times xi y will not be xi x squared, but rather it will be xi x xi y. Is that okay? Plus u xi x eta y plus u xi x y. Is that okay? So now let me expand that one. This time this is going to be u xi eta. I say that this one you can interchange them. Nothing happens to it. Xi y eta x. I like bringing the x first. So let me write it. Eta x xi y. So we move on to here. This multiplied by this, you're going to have u eta x eta y. Is that okay? Plus u eta xy. So this is what you're going to get. Now, so this becomes the formula for uxy. The formula for the x, the xx is this. Okay? And the formula for only ux is this one. Okay? Yes, so these are the formulas we are going to get. A little bit uyy and the uy. So let's prove that formula too. So okay, let's look at the uy, which is what? U xi y plus u eta y. So meaning that if I want uyy, I'm going to have, let me hold uy and differentiate u xi. So for the u xi, if I differentiate, it becomes u xi y plus u xi eta y. like this. Okay, plus, now I'm going to hold this and I'll differentiate this. So if I hold this and differentiate, sorry, I'm going to hold this and differentiate it. So if I hold it, that'll give me u xi. Differentiating xi y, that will be xi y y. Is that okay? Because I'm differentiating with respect to y. Then I will come here, which is plus. Now I'm holding itai y, differentiating u itai xi y plus u itai y. Then here I'm going to hold this, differentiate this. This will give me itai y. Please don't be confused with what I'm doing here because I've already shown you how to do it. You can use that diagram and it will guide you. And as you practice, you become used to it. That's all. Now, if I expand this, I have uyy equals u xi. With xi y times xi y will give you xi y squared plus u xi itai y. This time this, that's what you're going to get. Plus u xi y plus this and that. You're going to have u xi itai, so you can interchange this, okay? Xi y itai y plus u itai y squared, because this is itai y times itai y, that gives you itai y squared plus u itai y. So in this case, I have uyy because u xi y squared like this plus, now this one and that are the same, so that will be 2 of u xi itai y plus u xi y plus u itai squared y plus u itai y. So this also becomes the formula for the uyy, and the formula for uy is this. Already you know it, and all this thing can be proved from the diagram that I gave it to you. So study that diagram very well. Thank you very much for watching. This is just a proof, okay? I'm going to show you the canonical form of it. This is just a proof of the formula.